We're going to begin our work in Chapter 2 with some vocabulary and setting the foundation for functions. As we move through Chapter 2, we'll be working with primarily linear functions. I'm going to have you pause the video right now so that you can copy down the 4 vocabulary terms: relation, function, domain, and range, along with their definitions. And then go ahead and copy the 2 mapping diagrams, and we'll talk in a minute. Okay, now that you have the vocabulary down, let's talk about a mapping diagram. With a mapping diagram, you're using 2 ovals to place all of your inputs on the left and all of your outputs on the on the right. So your inputs are all of the x values that you might plug into a function, and the y's are all of the possibilities that you might get out. In this mapping diagram over here on the left, this is not a function. This does not represent a function because 1 input gives you 2 outputs. Notice that 3 maps onto 5 and 3 maps onto 7. This makes it not a function. Instead, it's just a relationship between values. And we could list this relationship using set notation. A set is a set of ordered pairs, the first ordered pair being 2, 3, and then 3, 5, 3, 7, and the final ordered pair being 4, 9. On the right, this mapping diagram here does represent a function because every x value maps onto 1 unique y value. So every x gives you only 1 y value. So if we were to think about this in terms of a set, our first ordered pair would be 1, 10, which is going to be a unique point. We'd also plot 2, 100, and then we'd go over to 3, up 100, and then our last ordered pair would be 4, 1000. So this set of ordered pairs does represent a function because each x maps only to 1 y value. All right, so another way we can determine whether or not a function is truly, or a relationship is a function, or a relation is a function, is by using the vertical line test. On the vertical line test, you take some vertical line, so I'm going to draw a vertical line over here, and then I'm going to slide it through my function. And as long as my vertical line only passes through the function at 1 point, I know that truly this is a function. So this is a function because the vertical line only passes through the function at 1 point. Over here on the right, this is not a function because it doesn't pass the vertical line test. So vertical line test is sometimes abbreviated VLT. This does not pass the vertical line test because check out this vertical line. It passes through the function more than 1 spot. In fact, it passes through it 3 spots. So the vertical line test is a test for determining whether or not a relationship of ordered pairs represents a function. The vertical line test says a vertical line will only pass through a function once. So that is the vertical line test. Again, a mapping diagram, if you mapped out all of the ordered pairs and every x mapped to only 1 y, that would represent a function. If you were looking at a graphical representation and a vertical line only crossed through the function at 1 point, then again, you'd be looking at a function. Something else that we need to be good at when we talk about functions is identifying the domain and the range. So remember that the domain is the set of all x values, and then the range is the set of all y values or outputs. Let's draw in a parabola here at example A. And for our parabola, we're going to make the vertex at over 2, down 1. So this is a vertex, and then my parabola is going to open upward from here. Now this parabola is going to continue to stretch to the right and stretch to the left as it moves towards negative infinity and positive infinity on the number line. So that means because it stretches to the left and to the right, what that means is that my domain will go from negative infinity to positive infinity, or in other words, it would be all real numbers. Now the range is my possible outputs. What are the possible values that I'll get out of this parabola? Well, I'm never going to get anything less than -1. But I do have a lowest point at -1, so I'm going to put a bracket around -1, and then I'll head off toward positive infinity. So that's my domain and range for this parabolic shape that has the vertex here at over 2, down 1. So for domain, you're thinking, what values would I come across as I moved from left to right? For range, you're thinking about what values would I come across on this function as I moved from the bottom to the top. All right, let's take a look at another example. How about letter B? Now for letter B, I just drew some random oblique line here, diagonal line. Looks like it crosses through maybe, I don't know, we could say that's maybe 2 on the y-axis, and maybe it crosses through -2 on the x-axis. But you know what, that doesn't really matter, because as we move from left to right, the domain is all of the possible values that I can plug into this function. And I can plug in anything from left to right, where if I were walking along the x-axis, where would I see function value? I'm going to see function everywhere from left to right. If I were walking along the y-axis, as I go from -infinity to +infinity along the y-axis from bottom to top, again, I'm going to see function everywhere I go, or I'm going to see a portion of that line everywhere I go. So the domain of that function would be from -infinity to +infinity. The range is also from -infinity to +infinity. Let's look at this third example. Take a second and copy down these ordered pairs, -3, 1, -2, 0, -1, -4, and -2, 6. So this is a set of ordered pairs. I could make a mapping diagram. I'm going to map -3 to 1. So this is my mapping diagram. The oval on the left contains my x's, and the oval on the right contains my y's, my outputs. My next input-output pair is going to be from -2 to 0, and then from -1 to -4, and then from -2 to 6. Uh-oh, this is not a function. This is not a function because one x value gives me 2 y values. So if one x maps to 2 y's, you know you're not looking at a function. But I can still give a domain and range. The domain is just a set of all inputs, the range is a set of all outputs, and the domain and range is separate from anything having to do with whether or not a function is, or a relation is a function or not. So now this time I can't really give an interval because I have these discrete x's. So what I'm going to do is just list the x values in a set in numeric order. So -3, -2, -1, and then I don't need to list the -2 twice, only list each number once. And then the range will be all of the y's. Again, I try and put them in numeric order. It's a set of numbers because it's a discrete set of ordered pairs, so like standalone ordered pairs. The lowest was -4, and then next in line would be 0, and then I should go 1 and 6. So there's my domain and range from that set notation.